Hey guys, today we're going to be talking about what are called families of functions. These are functions that are related to each other, and we can actually get multiple functions from what's called a parent function. Alright, so if we have just f of x, that's sort of our general function we've been working with. This represents what's called the parent function. And from this parent function, we can create other functions using what are called transformations. All right, we've got four types of transformations. We've got the first two here. We've got vertical translation. This means we're moving our function up or down. So if you were to graph out the function, we would have shifted the whole thing up, or we would have shifted the whole thing down. And the letter that we use to represent that is k, and k is either going to be added or subtracted outside of our function, and that'll mean it's going up if we're adding or down if we're subtracting. Horizontal translations are very similar, but instead of adding or subtracting outside, we are adding or subtracting inside the parentheses there. We're adding or subtracting what we are plugging into the function. And the other important thing to note is that if we are subtracting h, we move to the right, and if we are adding h, we are moving to the left. So it may seem a little bit backwards of what you would imagine, but if we are subtracting h, we shift our whole function to the right, that many spaces, and if we are adding h, we shift our function that many spaces to the left. All right, we have what are called stretches and compressions next. So basically this just happens when we have a letter a in front of our function. So a is multiplied by our function, and if you multiply a function by a number that's bigger than 1, it stretches it out, makes everything taller, and so we call this a stretch. And if you multiply our function by a letter a that is less than 1, so let's say 1/2, if you were to multiply a function times by 1/2, it would make everything very, very short. It would compress it together, and so we would call this a compression. So it's basically doing the same thing both times, but one stretches it out and one compresses it together. The last type of transformation we have is called a reflection. Both of these are going to involve negative numbers, and the first type is when we just have a negative on the outside. So we have multiplied our function by a negative number. And this is a reflection across the x-axis. So it's reflecting top to bottom like this. It would basically flip from the top down this way. The second type of reflection that we have is when we plug in a negative x inside of our function, and this is a reflection across the y-axis. So this is going to flip side to side. So if it starts over here, it would flip over here. And this is what we call a reflection across the y-axis. So here for an example problem, we're asked to write the function rule g of x. So g of x is just the name of a new function after the transformation of f of x equals 2x. So f of x equals 2x is our parent function, and we want to get a new function that we're going to call g of x. And we're told to translate to the left 5 spaces. So we need to translate our original function right here to the left 5 spaces. And if we think back to the notes that we just saw, we should remember that for a horizontal translation, translation side to side, we have to add or subtract a number inside the parentheses. So since we're translating to the left, that means we're going to add 5 inside the parentheses. So we would have f of x plus 5, basically. We would have f of x plus 5, and so we would need to plug x plus 5 in for the x that we have right there. So this would be equal to 2 parentheses x plus 5. So now we need to take this 2 and multiply it times both things inside the parentheses. So we get 2x plus 10 over here on the right side. Now, rather than calling this x plus 5, f of x plus 5, we're just going to call this g of x because we're told that the name of our new function is going to be g of x. So I'm just going to call this g of x down here. So this is our answer right here. We're done with this, and this isn't anything dramatically new, but it's just wording questions in a way that we haven't seen before.